Right. Now I joined in the meeting with my audio. Am I audible? Yes. Can you see my screen? Yes.
Yes, sir.
Okay. Thank you. So we'll continue from this. So here I made the observations. I table here. I made a table with my observations, right? So here I can modify this because I got the relation between the focal length F is equal to 30 centimeters and R is equal to 60 centimeters. Then I know the positions. So here simply I am rough diagram giving you. So this is what pole of the mirror, right? This is what pole of the mirror. Then here simply what is its center of curvature? Located at 30 centimeters. Sorry. What is its center of curvature distance? Anyone? At what distance? Center of curvature. Oh, very good. 60 centimeters. Then what about focus distance? F.
30 centimeters.
30 centimeters. Why? Here it is already we know. Non-focal length F equal to 30 centimeters. Focal length is what? The distance between the pole and the focus. Right? Then what is radius of curvature? The distance between the center of curvature to the pole or pole to the center of curvature. So am I clear how I identified? I think it is clear. Then look at here. Simply, I have mirror here, right? With noun F and noun center of curvature. Look at here. I am using the object, right? As arrow here. This arrow I am using as object. When I place the object at 60 centimeters, where my image is obtained at 60 centimeters, what that image characteristics? Same size and it is inverted, right? Same size and it is inverted. Is it clear or not? Yes, clear. So now we'll go for another. So I'm giving you the position actually, position of the object. So here, what is the position we chosen? It is at C. Clear? 60 centimeters is what? At center of curvature. I am clear? I am deciding the position of object with known points in front of the mirror. What are the known points of in front of the mirror? Known points are focal length and center of curvature. Right? These are known to me. Right? So at that places, I am placing the object. So I am deciding. So 60 centimeters is one of the position for us. So 60 centimeters is at the center of curvature. What about 50 centimeters? Where it is located? Here it is located. Then the object is shifted to 50 centimeters, right? 50 centimeters. So 10 centimeters gap. So where it is located? In between C and F. So this position we can call it as F and C. This position is what? F and C. Am I clear? Any confusion I am creating? Use quick response if it is clear. Wasting the time. Okay. So it is clear. Then we will go for the next position of the object at 40 centimeters. Right? At 40 centimeters. Right? So 40 centimeters, where it is? It is again between F and C only, because F is 30 centimeters, right? F is 30 centimeters and C is 60 centimeters. If you maintain 40 centimeters, it is lie between F and C, right? Then we'll go for the next. So what is next position? We placed the object. Sorry. What is the next position? Here I placed the object. I'm clearing this. Just a second. Right. Now the object is placed at 30 centimeters. Is it? So when the object is placed at 30 centimeters, right? What is the position with noun point? It is at F. It is at F. Is it clear, everyone? With the noun point, the distance I am linking with the noun places in front of the mirror. That noun places are focal length and center of curvature, or focus and center of curvature. So relating the positions of the object which we used in the lab activity. Next position is what? 20 centimeters, 10 centimeters. Anyone?
Between pole and focus.
So 10 centimeters and 20 centimeters, it is between pole and the focus, right? So these are the noun places we linked, right? So now I am changing this table. What we discussed with that, I am linking. So these positions I am linking with noun places, right? With noun places I am going to link this, right? So we'll go for the next one. So here I am using these values to modify this table, right? So I am using the table newly now with the 5 columns, right? And the number of rows 7, right? Why I am choosing number of rows 7, sir? Look at here. So this is pole, this is focus, this is center of curvature. So I have possibilities to place the object at very far distance. We can call it as infinity, and just outside the center of curvature I am calling as beyond. At center of curvature, right? Next between F and C. Next at focus. Next between. How many places I got? I'm giving you the counting numbers for them, right? So this is first place, second place, third place, fourth place, fifth place, and sixth place. How many positions are there to put the object in front of the mirror with noun points? Anyone give me the count? Give me the count. 6. 6 positions are possible in front of the concave mirror. Am I clear? Am I clear? Noun positions for the object 6, right? One is infinity. We cannot show the object because we won't go that place, right? So in that case, infinity case, no object shown in front of the mirror. So that will clarified in the ray diagrams, right? So these are the places. For that, I taken 6 columns with a different color, 1 column to note down the characteristics. So what they are here? Position of the object, position of the image. Is it enlarged image or diminished image? Then inverted image or erect image? Then real or virtual. So these are 4. These 4 are called as, right? Position, size, type of image according to the facing direction and according to the formation of image on the screen or surface, right? These 4 are called as characteristics of a image. These 4 are what is characteristics of image we are noticing in this table, right? So I will clear this information, then we will write down. So when the place selected for the object is at infinity, right? Very far distance. Where you get the image? That is at focus. Small image. For this, I'll give you the example. So I'm writing the first positions of the object, right? So first one is, what is first one? We observed activity 2. Object used as sun. Sun is object and the image is formed on the screen as point image bright spot, right? Object position is infinity, very far. Image position is decided as focus. So with that, I am writing the characteristics using activity 2. So I will write down the characteristics, right? So I will write down the characteristics. It is point image and it is inverted or erect. We cannot decide because it is a point. How you say it is inverted or erect? No, it is real image because that a bright spot observed on the screen. When the object is beyond, that means at 70 centimeters beyond center of curvature, because radii is equal to what? 30 centimeters. So this point, radii is equal to 60 centimeters. So this 60 centimeters distance is what? Center of curvature position. So at center 70 centimeters, what the characteristics we are written here? Diminished, inverted. And the type of image is what? Inverted image is always real. So note down that. So it is diminished image, inverted image, and the type of image is what? Inverted image is always real image. Then, sorry, what happened? Something I missed out. Just a second. Have you seen my screen? Use your quick reaction. Screen is visible. Right. Okay, here simply I'm going for the next one. At C. At C means what? At 30 centimeters distance. At a 30 centimeters distance. So what are the characteristics I observed? But here in this case, I am not going to write any characteristics. Just I am giving a, sorry, at C means 60 centimeters, not 30 centimeters. At C means 60 centimeters. Are you following me or not? Just find out my mistakes. So at C, it is 60 centimeters. So where is 60 centimeters? This first one, right? So what are the characteristics we know? It is same size and it is inverted. So inverted image is always real image. Then between F and C, is what? It is at a 40 centimeters or 50 centimeters. This is between F and C. F is 30, C is 60. So 40 and 50 in between them, right? So we have that here, right? So we will note down the characteristics in the table. It is enlarged and inverted. So inverted image is always real image. Then next we will go for another characteristic. So F is 30 centimeters. So when the object is placed at 30 centimeters, I got these are the characteristics. So I am writing the characteristics as blank because I want to go to infinity distance. So I cannot see the image on the screen. So I am not writing any characteristics. So at infinity distance, just we will give the blanks for the characteristics. If particularly you are writing, you can use this also. It is not a mistake. Enlarged, sorry. It is very enlarged, highly enlarged, infinity distance and inverted. It's not a problem. Then between F and P, what is between F and P? F is 30, pole is 0. So 0 to 30 centimeters. What we have here, 20 and 10 is there. So for that, what I got the characteristics? Eyes enlarged, virtual and erect. So here it is erect. I written inverted. This is mistake. This is erect image. Last character mistake. Erect image. right? It is erect image. So enlarged, erect, and virtual. Have you seen this modification of table? Any confusion? With the lab activity values only, I modified the table. Do you have any confusion? So for this, just you follow this logic. Pole, focus, center of curvature. Center of curvature distance is 60, focal length, focus 30. So with that, you can match these positions. If any confusion, just ask me. Otherwise, give me your quick impression, reaction. Everyone. So everyone is clear about this. Kaushik, Tejaswini. Any confusion? Right. Thank you. So we'll go for the next one. Right. Okay. So see your textbook. How many of you have the textbook? I don't know. If you have, open the page number 17. This table is given in what we have learned in the page number 17. And ask it to write down the table in the page number 6. In the page number 6. Page number 6 and page number 17. So that information completed discussion in the discussion. Right. So shall we go for the next? Use your reaction. Okay, we will go for the next one now. So here we will go for this characteristics observed by us by the ray diagrams. So already we learned in the previous class rules to draw the ray diagrams, right? Rules to draw the ray diagrams. So using that rules, I'm going to draw the images, right? So first of all, I will draw the image for the position of the object, which is placed beyond the center of curvature, right? Which is placed beyond the center of curvature. So I will show you the characteristics. When you place the object beyond the center of curvature, what you got? Characteristics. Note down this on the paper. Between F and C, diminished, inverted, real. Note down on the paper. We will verify this. Have you noticed? Raskunara? Okay. So remember these characteristics. We will verify with the ray diagram. Are they correct or wrong? Okay. So rough diagram we are drawing. So that is ray diagram only, not rough diagram. I will show you that characteristics using the ray diagram. Okay, so object is placed beyond the center of curvature. So for that, what we required? First, principal axis. I am giving you the process of drawing ray diagram. First of all, use your paper horizontally, then draw the line as you see on the screen using the scale, right? Use the long scale always, right? Use the long scale, 30 centimeter scale, right? So now identify the center first to cut the arc. So I'm using here directly, right? So pole identified and at a distance equally 5 centimeters, 5 centimeters, totally 10 centimeters, identifying the focus and center of curvature because we made a relation. Focal length is half of the radius or radius is double to the focus. So I used focal length 10 centimeters. I used focal length 10 centimeters, sorry, 5 centimeters. And I used the radius of curvature 10 centimeters. That logic only I have shown. Okay. Right. So see again. So 5 centimeters gap I followed, right? From the pole. So they are identified as focus and the center of curvature. Any confusion in this? So this is required by you. Any confusion? If nothing, use reaction. Right. So next, what to do? We have to place the object. What is the position for the object we chosen? It is beyond the center of curvature. So where is your center of curvature? Here. So where I am going to place the object? Outside. Beyond means outside. right? We can call that position as beyond. So remember that. So I am going to use the object as upward arrow here. I am using the object upward arrow here. So use upward arrow. That upward arrow also I am following logically. Exactly, it is equal to the width of the scale. Why, sir? To get the parallel ray from the top of the object easily. So now this is object for you, right? Upward arrow is object for you, right? Then I am choosing two rays. That means the rules which we discussed, which are possible to you, R1, R2, R3, among these three, which are possible to you. So here R1 is what? Parallel to the principal axis. R2 is what? Passing through focus. R3 is normal incidence along with the normal. So all are possible. But here if I choose along with the normal, it will go like this. Do not meet the mirror. So I won't go for the third ray. So I will choose R1 and R2. So what is R1? Anyone? What is R1? What is R1? Rule 1 or ray 1. It is parallel to the principal axis. So draw a line parallel to the principal axis using the width of the scale as it is, as you see on the screen. Is it clear, everyone? I am following easy method. Follow yourself the same trick. Okay, so I completed drawing the R1. Rule 1 is used, right? Then we'll go for the next one. So here, how many rays you are choosing? That rays compulsory from the same point. That point is what? From the top of the object. Compulsory it is. Why? This image you are trying to obtain, right? So that I am explaining you here. So we'll go for the next process. Already it is generalized. When a ray incident on the concave mirror after reflection, what about the reflected ray? Anyone? Anyone?
Passes through focus.
Very good. It passes through the focus. So directly, without measuring the angle of incidence and angle of reflection, complete your reflected ray. So use your scale. Okay, I am choosing one more ray here from the same point. So avoid your confusion. I am choosing the second possible ray also. That is what? Here, passing through the focus, right? From the same point of the object. So this is what? R2. Then tell me the behavior of R1. It is passes through the focus after reflection. So put your scale as you see on the screen, joining the point of incidence by the R1 and focus. Complete your reflected ray. It is according to the rule 1. Any confusion? Any confusion? No confusion. Okay. So R1 behavior is completed after reflection. Then R2 behavior. Can anyone? R2 behavior. Rule 2.
Becomes parallel to the principal axis.
Very good. It becomes parallel to the principal axis. So parallel line I am drawing from the same point of instance. So do you got any converging point of reflected light rays? That means they can meet at a common point after reflection. Say the answer. Do they
Yes,
meet
sir.
reflected light rays?
Yes, sir.
Reflected light rays. These two are reflected light rays. Do they meet each other? Yes, they are going to meet at this point. Look at this spot. This is what? Image point of the point you chosen on the object, right? So the object forms the image at this spot. Is it clear, everyone? Right. So you are clear. Right. So reflected light rays are going to converge. So when the actual meeting point of reflected light rays observed, what type of image you will get? By the actual
Real.
converging point, real image, right? With the converging light rays, what you will get? Image, real image. So what type of image you will get here? Real image. That means if you use the screen to move in front of the mirror from this place, so you will get the image on the screen at this distance. So this is the meaning of this diagram, right? Everyone is clear? Use your quick reaction. Ray diagrams important, right? So here simply I am drawing a vertical line onto the principal axis. Clear? Look at here how I am drawing. From image point to the principal axis, from image point to the principal axis, perpendicular. And I shown direction of the arrow. Why I shown downward? Why I shown downward? Because it is obtained below the principal axis that I am showing. So now look at your image. Where it is image? Below the principal axis or above the principal axis?
Below the principal axis.
Right. Below the principal axis, your image is formed. What type of characteristics you can write? It is inverted or erect. Facing sides are opposite each other. So what word we can use? Object is facing or above the principal axis and image is placed below the principal axis. What word we can use here?
Inverted.
Inverted.
Inverted. Then compare the sizes.
Image is smaller than object.
Right. Size is smaller. So what word we can use here to indicate smaller?
Diminution.
Diminished. Diminished. Okay. Then what about the position? What about the position?
Between F and C.
Very good. Between F and C. What about position of object?
Beyond center of curvature.
Beyond C. Right? So, is it real image or virtual image?
Real image.
So, what I got the characteristics? Real, diminished, inverted image is formed between F and C. Real, diminished, inverted image is formed between F and C if the object is placed beyond center of curvature. Now compare these results with your noticed values. నేను చెప్పాను కదా నోట్ చేసుకోమని కంపేర్ చేయండి. ఏమొచ్చింది ఆన్సర్? Anyone? Object is beyond. Object is beyond. What you noticed?
We got same values.
Both are same.
Both are same? Right. Both
Yes,
are
sir.
same. We got. So here you are able to verify with your ray diagram or not. So any result we noticed in the table will be verified with the diagrams. Is it clear? Is it clear? So ray diagrams are help us to find out the characteristics of the image for any position in front of the mirror. Any position in front of the mirror. So now I will show you the positions. Now I will show you the positions here only. Just wait. So at infinity, we cannot show the object. Not showing object. Right? So in this case, just we will use only parallel rays above or below principal axis. Clear? Clear? Because infinity distance we cannot find. So for this, just we are using the parallel beam of light rays. Antak minchi em use cheyamo. Right? Then what is next position? It is what it is, the position, can you name it? Can you name it? Where it is
Beyond center of
outside the center of curvature, we can call it as beyond. This position is what? Beyond center of curvature. Next, we will go for another position. Look at the position here. Right? Where it is? Where it is? Exactly on the center of curvature or at center of curvature. What is the next possibility here? Just getting the object inside the center of curvature, but outside the focus. So what we can call this position is between F and C. Then what is the next possible position? Here it is, exactly onto the focus. Right? So the position we can call it as at focus. Then what is next possibility here? Next possibility is inside the focus. Right? So we can call the position as between P and F. So how many positions you got? Counting. Number of positions. Anyone? Number of positions.
5.
Look at once again. Without object also one position is there.
6 positions.
6 positions. Number of positions are what?
6.
6. Clear? So how many ray diagrams you can draw for concave mirror? How many ray diagrams for concave mirror?
6 ray diagrams.
6 ray diagrams, right? According to the positions. So number of positions 6, number of diagrams also 6 for concave mirror. What about convex mirror? That we will discuss in the later next classes, right? So what is the time now? It is 8 o'clock, right? So any confusion left in these topics? Any confusion left in this topic? So no doubt for Kaushik. Okay, you can leave now. Okay, Medashree, you can leave now. Tejaswini, you can leave now. Medashree, okay. Sri Charan, okay. Abhinay, okay. Surajita, okay. Rohit, okay. Right. Everyone, you can leave the meeting now. So this today's class completed. Thank you for joining in the live.